Now we have several methods of differentiation. The first one is first principle. The first principle. So if you are given a function f of x, if y is equal to f of x as your function, and you must find the derivative of y with respect to x, or the derivative of this function f with respect to x, that's how we write. This will be the limit. Introduce a variable h and take it in f where there is x, put x plus h, subtract the whole f of x, then divide by h. We go straight to examples. Our first example is coming from question 2 of draw sheet 9, part 1. So example 1, from first principle, or we can put it here, from first principle, from first principles, find okay, now find dy dx. 1, y is equal to 2x plus 1. Now we said dy dx by definition should be found by the limit as h goes to 0 of f of x plus h minus f of x, divide everything by h. This means that our f of x is 2x plus 1. So our f of x plus h is going to be 2, while there's x, put x plus h plus 1. So we'll get 2x plus 2h plus 1. So we'll have the limit as h goes to 0 of 2x plus 2h plus 1 minus 2x plus 1, divide everything by h, giving us the limit as h goes to 0, 2x plus 2h plus 1 minus 2x minus 1 over h. But 2x minus 2x is 0, and 1 minus 1 is 0, so it remains 2h over h. This is just the limit as h goes to 0 of 2, but the limit of a constant is just a constant. Example 1, the easiest. Then we go to example 2, just an advancement. Example 2, we are just following the whole question 2. x3 plus 3x squared minus 2. Now we know that dy dx is the limit as h goes to 0 of f of x plus h minus f of x, everything over h. So then we are saying if f of x is x3, plus 3x squared minus 2. Then f of x plus h is going to be x plus h power 3 plus 3x plus h squared minus 2. We expand this, it will give us x3 plus 3x squared h plus 3x h squared plus h squared plus 3x squared plus 2xh plus h squared minus 2. So that it becomes x3 plus 3x squared h plus 3x h squared plus h squared plus 3x squared plus 6 plus 6xh plus 3h squared minus 2. And then now we bring down our dy dx, which is the limit as h goes to 0. F of x plus h is what we have here. Three x h squared plus h3. This is h3 actually. Plus 3x squared plus 6xh plus 3h squared minus 2 minus x3 plus 3x squared minus 2. Everything divided by h, giving us the limit as h goes to 0 of x3, 3x squared h, 3x h squared h3, 3x squared, 6xh, 3h squared minus x3 minus 3x squared plus 2, everything over h. So now we can see that x3, this has negative x3. 3x squared, this has negative 3x squared. Negative 2, this has positive 2. So what we have remained with is the limit as h goes to 0 of this plus this, that over h, which is the limit as h goes to, remember that we said our target is always finding a way of substituting the h, of substituting this variable that goes to this number, of putting this number where there is this variable. So in this case, we want to put a 0 where there is h, but because h is in the denominator also, we can't put a direct 0 there. So we must deal with the h first. The good part is that all the things up there have h. So if we factor it out, we'll have 3x squared plus 3x h plus h squared plus 6x plus 3h, everything over h. So this h and this one will cancel. Then now we can substitute where there is h. We'll be taking a 0, 3x 0, 0 squared, 6x plus 3 0. This is giving us 3x squared plus 6x. As our dy dx. Questions? if they are n.
Sir, on the beginning of these stages here, why didn't we group the like terms? Like on the second stage here where you started cancelling in red.
I said canceling. So grouping the like
Wouldn't it
terms,
have been it's just the same?
it's the same thing.
Oh, okay.
Because we would have said x power 3 minus x power 3, 3x squared minus 3x squared, which is 0. So the cancelling there is actually subtraction. Okay. So next, we are going to, there was no part 3, there was just part 4. But why should we miscount? So put it as 3, since we know how to count. 2x minus 1, like that. By definition, we are looking for dy dx. This is the first thing that you always write if they say use first principle. Because even if it's time up and you have put this, you get the marks for doing that. Because if you don't know this, then you couldn't have answered this question. Then, so if y is f of x, then what will be f of x plus h? It will be the root of 2x plus h minus 1, which is the root of 2x plus 2h minus 1. So we come here and say this is the limit as h goes to 0 of the root 2x plus 2h minus 1 minus the root of 2x minus 1 over h. So we are wondering in the first topic why we needed to learn surds. It's so that when we come here, we can use that concept. How do we extract h from the numerator there? So that it can come down and cancel the h that is down here. The only way out is to rationalize the numerator. 2x plus 2h minus 1 minus 2x minus 1 is to multiply this numerator by the root of 2x plus 2h minus 1 plus the root of 2x minus 1 divided by h, the root of 2x plus 2h minus 1 plus the root of 2x minus 1. So that we get the limit as h goes to 0. Root by root, if the things inside are the same, we just get the things inside. And since they are positives, we don't need brackets. And then plus root times root, we can choose to put them as root times root. It's all right. Minus root times root, you can choose to write them in n order since they are multiplying. Since one is negative, the other one is positive, so the whole thing will be minus. And then root times root, there's a minus outside, so put in the brackets. And then the down thing remains as if nothing has happened on top there. so that we get the limit as h goes to 0. But you can see that these subtract, giving us 0. And when we expand, we'll have the limit 2x plus 2h minus 1, then expand there, we'll get that over the h, and then the root of 2x plus 2h minus 1 plus 2x minus 1. This is equal to the limit as h goes to 0. You can see that this is just a 0, another 0, and then this h can cancel that h, so that we get 2 over the root of 2x plus h, I mean 2x plus 2h minus 1 plus the root of 2x minus 1. Close here. And there's nothing to close anymore. So at this point now we can see that even if we take where there is h, we take 0, our function will still be defined, meaning that we have found the limit. So 2 over the root of 2x minus 1 plus the root of 2x minus 1. This is just 2 over 2, the root of 2x minus 1, which is nothing but 1 over the root of 2x minus 1. So these, they tend to be complex a bit. You need to be extra careful so don't make mistakes when you're doing the multiplication there. And remember that wherever there are signs, we actually do rationalize. Okay. So we can get tired before we finish this whole question. Y is equal to 1 over x plus 1. So we already know dy dx can only come out through the limit if we have to use first principle, f of x plus h minus f of x over h. But f of x assumed to be 1 over x plus 1. So f of x plus h is assumed to be x plus h plus 1. We'll go back and substitute. This is the limit as x goes to 0. 1 over x plus h plus 1 minus 1 over x plus 1 all divided by h. This is just a limit as h goes to 0. Common denominator is x plus h plus 1 multiplied by x plus 1. And the numerator there will be x plus 1 minus x plus h plus 1. Dividing by h here is the same as multiplying h in this denominator. It's like we have a over b divided by h over 1. It will be a over b divided by h over 1, which will be a over b multiplied by 1 over h, which is a h multiplied by b, where b is this whole thing here. So that if we expand our numerator, we'll get x plus 1 minus x minus h minus 1 over h, x plus h plus 1, x plus 1. That is the limit as h goes to 0 x minus x 0, 1 minus 1 0. So we get that over h, x plus h plus 1, x plus 1. So that this guy and this guy cancels. We remain with a limit as h goes to 0, negative 1 over x plus h plus 1, x plus 1. Where it is now, when you substitute where there is h, you take 0, things will still be defined. This will be negative 1 over x plus 1 multiplied by x plus 1. So that if you want, you can write it as x plus 1 squared, if you want. So this was the mini so that you are asked to answer 1 over the root of x plus 1, which should be dy dx is the limit as h goes to 0, f of x plus h minus f of x over h. So that you understand that our f of x plus h will just be 1 over the root of x plus h plus 1. So when you come here, you'll be dealing with the limit. H is still going to 0, 1 over the root of x plus h plus 1 minus 1 over the root of x plus 1. Everything divided by h, so that we have the limit as h goes to 0. The common denominator will be x plus h plus 1 multiplied by x plus 1. Everything down will be root x plus 1 minus x plus h plus 1. Now, instead of saying over h, we'll just multiply h by the denominator from this extraction here. Okay, then rationalize the numerator again. Rationalize the numerator. So we'll have the limit as h goes to 0, root of x plus 1 minus root of x plus h plus 1 multiplied by root of x plus 1 plus root of x plus h plus 1 over h root of x plus h plus 1 root of x plus 1 root of x plus 1 root of x plus h plus 1. So that we get the limit as h goes to 0. Root times root, just get 1. Then these cross roots in between here, we know that even if we do, as long as you're rationalizing, they will cancel each other. And so just remain with negative. The inside, so it's supposed to come out to be negative x plus h plus 1. So that when you expand, it will be negative x minus h minus 1 over h root of x plus h plus 1 multiplied by root of x plus 1 multiplied by x plus 1 plus x plus h plus 1. And so this x and that, this one and that, we remain with the limit as h goes to 0, negative h over h root of x plus h plus 1, root of x plus 1, root of x plus 1, root of x plus h plus 1. So that this and this can cancel. Now we have made with negative 1 over whatever there is h now, we can take 0. So we have x plus 1 multiplied by x plus 1 multiplied by x plus 1 plus x plus 1. This is the same as negative 1 over root of x plus 1 multiplied by root of x plus 1. We just get x plus 1. And then we'll have 2 of the root of x plus 1. You can write it like this as our solution. So unless there's a serious question. So that if we go to 6, y is equal to x plus 1 over x minus 1 dy dx is going to be the limit as h goes to 0. Now we are used, so we just go direct to x plus h plus 1 over x plus h minus 1 minus x plus 1 over x minus 1, everything over h, so that we get the limit as h goes to 0. Common denominator on top, which will multiply by the h down. And then remember that when you're dividing there, the h is silent. The h is acting as if it's not there. When you're saying x plus 1 minus 1 in the denominator here, so that you get x plus h plus 1 multiplied by x minus 1 minus x plus 1 multiplied by x plus h minus 1. That's where now the h is appearing. When you're about to write it as in an independent denominator, just remember that your fraction is there. Then you expand. So x squared minus x plus hx minus h plus x minus 1 minus x squared plus xh minus 1 plus x plus h minus 1. Everything over h, x plus h minus 1, x minus 1. And then the limit as h goes to 0, we'll get x squared minus x plus hx minus h plus x minus 1 minus x squared minus xh plus 1 minus x minus h plus 1 over h, x plus h minus 1, x minus 1. Then now you notice that this minus x and this plus x, they'll go. This x squared and that minus x squared will go. What else? This hx and the minus hx will go. And then
-1 and +1.
-1 and +1. Okay, so the remaining things, there's trouble in the village because this thing must divide h, but we have 1 minus x there. How? Recheck. So x squared minus x plus hx minus h plus x minus 1, x squared plus xh minus x. Oh, okay. This is supposed to be minus x. And then x plus h minus 1. So this is supposed to be minus x, so that it is also cancelled. This guy must be cancelled in this one. Okay. Then now we have the limit as h goes to 0. Negative h minus h, we have negative 2h over h, x plus h minus 1, x minus 1. So if we cancel here, we have the limit as h goes to 0, negative 2 over x plus h minus 1, x minus 1. So that when you substitute where there is h, you take 0, we'll get x minus 1 multiplied by x minus 1, which is negative 2 over x minus 1 squared. So the 7th one, y is equal to 3. By definition, dy dx should be the limit as h goes to 0 of f of x plus h minus f of x, everything over h. What happens? So we get f of x plus h, since f is a constant, f of x plus h is still a constant, minus the whole f of x divided by h. So we get the limit as h goes to 0 of 0 over h, giving us the limit as h goes to 0 of 0. Limit of a constant is a constant. So I think for this type of functions, first principle has been exhausted. So you expect only this type. For this type of functions, this is what you expect on first principles. So that when you're still quiet like this, we can log out and come back to do other types of differentiation.